In today's video, here is a nice problem. It's coming from Hungary Mathematical Olympiad edition 1911, which is old problem. So here is a following statement: for all n as a natural number which is strictly superior to number 1. So our goal, we are going to prove 2 to the n not divides 3 to the n plus number 1. Okay, indeed this problem was done before in one of my old videos. It was done by different method, which is lemma, left-hand exponent. So at the end of this video, I will add the link to the comment section where we can see both methods. Okay, you guys also, you can get your own methods. Let me know in the comment section below what you get. By the way, don't forget to hit the subscribe button and support the channel by like, comments. So now let's get started with this one. So in fact, I'm going to do this one by the way of contradiction. We are going to assume this one divides this one. At some point we are going to, and we start building the contradiction. Okay, for all n which is superior to 2, okay, or n strictly superior than number 1. So by the way of contradiction, suppose 2 to the n divides 3 to the n plus number 1. Okay, so this one equivalent according to the divisibility statement, 3 to the n plus number 1, which equals k is multiplied by 2 to the n, like this. Okay, the next thing up, since we have n is superior to 2, which means both sides of this equation will be divisible by number 4. Okay, so by doing that, I get 3 to the n, which is, I'm going to split number 3 into 2 parts. 3 equals 4 minus number 1. So I get here 4 minus number 1, all is raised to the n as an exponent, plus number 1, which equals k is multiplied by 2 to the n. So as you see here, since we have assumed n is superior to 2, which means the minimum value n can take, which is number 2, so this one becomes 4. So this one always, for all n is superior to 2, it will be divisible by number 4. So let's do that for the both sides of this equation. So I get here 0 here, I get 0 here, I get minus number 1, all is raised to the n as an exponent as well, plus number 1, which is a congruent to 0 mod 4. Okay, this one is 0. So let's take number 1 to the right. I get minus 1 to the n, which is a congruent to minus number 1 mod 4. So now I get this expression where, okay, when we have both remainders equal to each other, when we have n is odd, if we have n is odd, this one is turned into minus 1, which is true. N must be odd. If n is odd, which means n is superior equal to 3. Okay, now let's go back to our setup right here. Also, since we have n is superior to 3, so this term now will be divisible by number 8. Okay, so which means let's reduce both sides of this equation to the mod 8. So I get here 3 to the n, which is a congruent to minus 1 mod 8. Okay, so I have ended with this nice expression here. So why is that? Because as you congruent to minus 1 mod 8. Now let's go through the chart to make the comparison between this remainder, which is minus number 1, and the possible values of 3 to the n as a reminders. Okay, so let's do that. So here is the following chart. Here is the following values. I get k in general. So I get here 3 to the k. Here is the following values: 0, 1, 2, 3, 4, 5, 6, and so on and so forth. Okay, so this one will be reduced to the mod 8. So you get the following values: number 1, because I'm replacing k with 0. So I get here 3. I get here 3 to the 2, which is 9. 9 is 1 more 8, which is the remainder is number 1. I get 3 here, 3 to the 3, which is 27. 27 is 3 more 24, 3 remainder. So I'm going to stop here because I see that I'm going to stop here because this one is enough. I see the kind of repeating here, 1 3 1 3. So this one keeps repeating all the way down like this, 1 3 1 3 and so on and so forth. Okay, so we get this one 3 to the key is belongs to this set 1 and 3. Since we get minus number 1 at the right hand side of this equation as a reminder, but the left hand side of this equation we get 1 and 3, which is contradict both sides of this equation, so this one it's impossible. What does mean impossible? We have contradicted our assumption here, so which means 2 to the n not divides 3 to the n plus number 1. Okay, so I have done this problem. If you have any comment or questions, just put it in the comment section below, or you have any different method you can provide as well, because this one you may solve it by different methods. Okay, so by the way, don't forget to hit the subscribe button and support the channel. Thank you for watching. I will see you next video. Bye.